Hi, grade 10s. Mr. McLeod here with today's lesson. We've been talking about transformations the past couple days. So I just wanted to explain this so that you have a good idea of what we're trying to learn here. So transformations is a big topic in mathematics, and you'll be working on transformations next year in math, and if you continue doing math. But for grade 10, we are talking mostly about transformations of quadratics. So the idea here is that we are taking some basic starting point, and for us in grade 10, our starting point is this most basic parabola, y equals x squared. And then we're trying to figure out, as we add things to the equation, as we add numbers in different spots in the equation, what does that do to the graph? So let's go through a bunch of these, and it'll make more sense as we go along. But first, let's get to know our starting point really well. So our starting point is always going to be y equals x squared. That's our most basic parabola. Okay, so let's graph this thing accurately. So I'm just going to put in different values for x, and then see what we get for y. So if we put in 0 for x, 0 squared is 0. So our kind of origin, as we already know, is 0, 0. Next, we've put in 1 for x. 1 squared is 1. So the next point on the parabola is 1 and 1. If we put in 2 for x, 2 squared is 4. So our next one in the parabola is 2 and 4. 1, 2, 3, 4. And let's put in x is 3. So if x is 3, then 3 squared is 9. So our next one in the parabola is 3 and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And the nice thing about parabolas is that they're symmetrical, so we can just mirror these points on the other side of the y-axis, and then we draw a nice smooth curve. I'll do my best here. There we go. So that's y equals x squared. That's our starting point. All right, next, let's add a negative in front of the x squared. And by now, you are well aware that this causes the parabola to open downward. But we want to describe this in a math way, and more specifically, we're trying to describe it in how does this original parabola changed. It doesn't tell you how it's changed if you just say, well, the parabola opens down. So what we say is that it's reflected about the x-axis. So I'll write this down. It just means that every point in the parabola is mirrored on the other side of the x-axis. So 0, 0 stays the same. But this point, 1 and 1, gets mirrored down here. So now it's 1 and negative 1. And then 2 and 4 becomes 2 and negative 4. 1, 2, 3, 4. And 3 and 9 becomes 3 and negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 is down there. Oops. 5, 6, 7, 8, 9. Okay, the next parabola, y equals negative 2x. There's a 2 in front. And as we've discovered so far, the 2 causes the parabola to be more narrow. So what we're going to say in a math language is that it's vertically stretched. If it's more narrow, then it's as if the parabola is, we grab kind of our graph at the top of the y-axis and the bottom, and we kind of pull it apart and stretch it, which means that it will decrease faster. So in this case, it'll actually decrease twice as fast. So we say that the parabola is vertically stretched. And we can actually be more specific. How much is it stretched? Well, it's stretched by a factor of 2. By a factor of 2. So that means that we're going to take the blue parabola and stretch it by a factor of 2. So that means that every point on the parabola is going to be 2 times farther away from the x-axis. So this point here that's at 1 and negative 1 is going to, when it's stretched, it becomes 1 and negative 2. And this point here that's at 2 and negative 4, when it's stretched, it's going to be stretched twice as much. So Negative 4 times 2 is negative 8. So actually it's going to go down here. 5, 6, 7, 8. And that's what causes the parabola to appear more narrow, is because it decreases faster. Okay, the next one is y equals negative 2x plus 5 squared. What we've got at this time is a number inside the brackets with the x. And what we've learned so far is that we call this number h. And if the number inside the brackets is positive, then we know that the h number is negative. So we always have to think of this number inside the brackets. We have to kind of think of the opposite of this. So this h is actually negative 5. Okay, and what we know about this number is that it moves the parabola left or right. And a negative h value moves the parabola to the left. A positive h value moves the parabola to the right. So this one is shifted or moved to the left, and the math term that we're going to use is called translating. So we can say that it's translated. Okay, so we're going to take the green parabola and move every point to the left. And lastly, the last transformation that I'll show you is this one, where we add a number to the end, and we're going to call that number k. So in this case here, k is 7. And what this k value does is it moves the entire parabola up or down. And of course, the math word for just shifting it is called translation. Okay, and there we have it. That is basically 4 different changes or transformations that we can do to a parabola. So why this is so powerful is because we can predict what the new graph will look like um, by knowing what changes or transformations are being done to our basic parabola y equals x squared. Okay, so let's take a look at this example here. We have y equals negative 1/3 x squared plus 10. The a value is negative 1/3, so we know that it opens down, or in other words, it is reflected about the x-axis. The a value is between 0 and 1, and anytime the a value is between 0 and 1, that means the parabola is increasing or decreasing slower, which makes it look wider. So it's as if we grab the top and bottom of the y-axis and compress them together so the parabola will open wider. Okay, and the last change or transformation is this plus 10 at the end, and we know that a number on the end moves the parabola up or down. If it's positive, it's going to move it up. Okay, one more. Okay, the flip side of this question is if you are given the descriptions of the transformations, then asked to come up with the equation. All right, so here we go. So if we take y equals x squared and we shift it up 2 units or translate it up 2 units, then we have to add, that's affecting the k value. So we have to add 2 units as the k value. So this becomes y equals x squared plus 2. If we translate the parabola 3 units to the right and 5 units down, then that's both the h and k value. So y equals, okay, 3 units to the right means that the h value is positive, but when it goes in the brackets, it gets the opposite sign, which is negative here. And then 5 units down, 5 units down should mean that our k value is negative, minus 5. Okay, the next one translated left 8 units, compressed vertically by a factor of a quarter. So this compression is basically telling us our A value. So our A value becomes 1/4, and it's translated left 8 units, which means our H value is negative, which means in the brackets it's actually becomes positive. And finally, stretched vertically by a factor of 7 and reflected about the x-axis and translated 13 units up. Okay, so it's reflected, which means it opens down. So that means the A value has to be negative. So y equals negative. Stretched by a factor of 7, which means it's really narrow. So our A value is 7. And translated 13 units up. So it's not moved left or right, so we just put x squared without the brackets. And we add 13 at the end to move it up. All right, so I hope that was made some sense to you. And that's it for now, and we'll talk to you later. Bye.